Hi, my name is Aiden.
My name is Alicia.
I'm Laksha.
And I'm Harin. So for our hackathon project, we present to you the COVID counter.
So who are we? We're 4 first-year engineering and iBiomed students from McMaster University. We entered the MacHacks AI hackathon with minimal knowledge about artificial intelligence and machine learning, and united as a team through our shared interest in expanding our knowledge. COVID-19 has impacted billions of people worldwide and millions across Canada. Government officials, health professionals, and citizens across the globe are very anxious and concerned about the state of the pandemic. So we wanted to find a way to keep people informed and make educated decisions regarding COVID-19 in these times of uncertainty. Our solution is the COVID counter. The COVID counter uses a linear regression model over a 7-day period to estimate the number of COVID-19 cases each subsequent day. After training and testing the accuracy of these models, it's possible to project and estimate future cases. This will help many people stay informed and make educated decisions based on the predictions provided by the COVID counter. Further applications of this program could even include the projection of ICUs to be used each day, projection of vaccination rates, and more.
So here's our algorithm. We started off by importing all of the required libraries that we would use throughout our program. We then found a URL online that has a CSV file with all of the data from Ontario with the respective dates and the increase in daily cases. We printed this URL to give the user access, and we also included this with file IO so that it may be downloaded to a folder for the user to open and the program can read from the file. This helps the algorithm be completely autonomous, as this will update every time the algorithm is ran. After reading the downloaded file, we take the required data. We only need the date and the total daily cases. To help better visualize this data, we use matplotlib and graph the total daily cases against the dates.
So to better understand our data and to help us visualize it, we simply printed the daily cases and the X values into a more readable format from the CSV file for both us and the viewer to see. And this is done through very simple print statements and variable assignments. So on the next slide, since we are beginners at machine learning and AI, we decided to use a very simple linear regression model. And one of the problems we faced while pursuing this option was that from the COVID-19 cases per day graph is not linear. So in order to solve this, we took a window size of 7 days and used that to project the COVID cases on the 8th day. And because the time frame is very small, we decided that it can be represented closely enough with the linear model. And in order to do this, we first had to take all of our COVID-19 data and split them into subarrays of 7 indices each, that each represents a day in the 7-day window. And after, we used the sklearn library to create training data and testing data for our algorithm with a 2-to-1 ratio split.
So we used a linear regression model from the sklearn library, and we applied it to our training data, which is Windows train and labels train. And then we predicted the labels using the predict method, and we inputted the Windows test data. So we calculated the mean absolute error using the built-in function to get a sense of accuracy of our model. We also plotted the predicted labels and the test labels together to get a more visual representation of the accuracy. And as for our final objective of our program, we predicted tomorrow's COVID cases in Ontario using the last values in Windows. And here we have our mean absolute error, which is 129, and our prediction for tomorrow's COVID cases. And as you can see on the graph, we have the predicted labels and the test labels together. Since we did use a linear regression model, it's not completely accurate, which shows the inconsistencies in the graph. But since we had such a small time period of 7 days, we were able to get a decent accuracy to estimate the values. And thank you for listening.